So, hello everyone. This is Mirza Arif Beg. So, currently I'm the lead engineer at Utilon. So, Utilon is basically a utility management product. So, it is built on top of ERP Next and Frappe framework. So, it is an end-to-end platform for all the utility sector. So, Utilon is basically a product built by Brontobright Technologies. So, they already have a decade years of experience in utility sector. So they have been implementing SAP solutions at large scale, but they were implementing SAP. So they just wanted to have a solution which is open and faster to develop and faster to deliver. So first of all, what is utilities? So utilities is basically uh, the providers of electricity, water, and gas, and they also need this ERP system. But their ERP system is quite different than the normal ERP system. So they have inventory management, they have customer management, they have vendor management, but their billing system is quite complicated. So I'll be going through the billing engine what we have built in Utilon. So in Utilon, they have dynamic tariffs as their formulations for the billing. They have slab-based billings, and they also have historical recalculations. So example, you have a calculation or a formula on January, and then you have changed it in February, and then you have changed it in March. But now if the customer comes up with an anomaly and says that there is something wrong with their consumption or their meter reading, the system has to go back in the January and has to use the January formula rather than the March current formulations. So basically, we have the major three doc types which handle all the billing engine. So number one is rate category, then rate and tariff. So first there is a customer lookup, then we do rate category lookup, and then rate defines what tariff to apply. So the computation goes from customer to tariff, but when it comes for configuration, it comes from tariff to customer. So in tariff, we have three sets of methods in calculation. So there is a block method, scale method, and a standard method. So I'll just go to, yeah. So this is how the type of block calculation, I don't know whether it is visible or not. So you have this rows which says lower limit and upper limit. So you define a lower limit and an upper limit. Then you define a rate according to that limit. And then you go on and go forth. And then you also have a from and to date. So that defines when to apply this and at what date to apply this. So example, if the consumption is 150, the first 100 is being taken from the first row, and the second consumption is being taken from the second row. That is how the block system works. And you can configure whatever number you want. And then you have scale. So scale is also similar to what block has, but the calculation method is quite different. So in scale, rather than taking sequentially on the rows, it directly takes the number wherever it lies. So wherever the consumption lies in the upper and lower limit, it takes from that range. And then you have standard. In standard, they basically mention at what kind of units cost what kind of price. So this is very basic. And then you have rate configuration. So tariff tells you what type of billing to apply, but rate configuration tells you how the consumption is being calculated, plus what condition it should apply. So if you see this second image, you have this consumption formula. So basically, even from the front end, you can write the consumption formula using some placeholders and keys, and you can define the condition at a same placeholder level. So in rate, basically, you can write the formula without having any hard-coded values. So this is basically, you can write all the formulations, placeholders, and keys, just like normally you type it in Excel. And then you have placeholders for customers. So this is where the customer doc type, we have added placeholders and booking details. So let me just zoom in if I can. Okay. So this booking details defines whether how much units can be used in subsidized units and how much units can be used in non-subsidized units. And placeholders are basically like the correction factor of consumption. So you can use this in the consumption methods. And also this application is multi-utility. You can define what utility it is, and you can define what UM it has to follow. So you can add electricity, you can add gas, you can add water, and then wherever the meter is being taken, automatically the utility type is taken. From there, the SEM or kilowatt or whatever the meter is, it will record by itself. And then you have meter reading. So in meter reading, basically there is a meter. They take the meter number, and then automatically when you take the meter number, the previous reading comes up. And then the meter reader will enter the current reading. And then it is basically previous reading minus current reading, you get the consumption. And from the consumption, you basically get the sales invoice. And also, while taking the meter reading, we are also taking an image of the meter reading. So we have a PW app. So this will basically take, you can take an image of the meter so that this image can be utilized on the sales invoice so that if there is any kind of fraud or theft happening, you can have an audit of the meter itself. And we have added a small feature which basically it takes the unit from the meter image and directly converts into a float value right in the app itself. We didn't use OCR just because OCR is basically reading all of it. We used a vision model so that it basically have the meter reading itself, not other values. So here is the sales invoice preview. So you have all the invoice items plus the meter image so that any audit or anything comes up, you can have an image of the meter itself. And there is another method of calculation, which is industrial customers. So what I have shown you is all based on residential customers. And now this is the industrial. So in industrial, you have two methods. One, you basically define the demand of the industry. And then if it exceeds or if it decreases, there are two scenarios of billing happening there. So if it decreases, you have this minimum demand charges being applied. So here is the invoice of industrial customer. So this is the normal invoice where there is no MDC applied, and that is the invoice where the MDC is being applied. So how do we run these kind of computation things at a runtime? So basically there are three major things which we have used. Number one is variable injection. So wherever there are variables, we are trying to convert it into a string in the database so that wherever you are mentioning any variable, that is being converted. The second method, the second thing what we have used here is safe evaluations. So just like normal how we use safe.eval, it is something similar to it. It is typically based on Python abstract syntax tree module. So it basically handles all the expression part. And then the third thing what we have used is fallback. So fallbacks are nothing but whenever you are having a, let's assume you are creating a key of correction factor. So when you're creating the key of a correction factor, you also have to mandatory add a value to it. So that, let's say example 0.5. So whenever the formula is not trying to connect to that the placeholder, it basically falls back to that value. So by doing this thing, even if there is a fallback or any kind of value miscalculation, the formula never dies. So it basically runs on, the whole computation runs through. So this is the whole process which I have explained you. So there is sales, this meter reading, and then from meter reading to sales order, all the executions take place. The tariff, rate category, and customer type. Yeah, so this application is live. So you can basically download it, install it, and run it through on your Frappe instance. And we are open for any PRs and issues if you find anything. All right, thank you very much. If you have any questions, please.